Good afternoon, welcome back. Now we further discuss about concrete gravity dams and their apparent structures. The basic layout of a concrete gravity dam is of triangular in section. There are two cases. In the first case, in first figure A, the top crest is not widened, but in the second shape, in the B figure 1b, there is extra widening provided in the crest sides for the passage of roadway or inspection of dam site. So basically, concrete gravity dam section figure B is a modified shape, or you can say it is a modified version of basic triangular shape. And in figure 1a, the basic shape, as you can see, the width of section, basic triangular section, is increasing towards the bottom. Why is that so? It is because that water pressure also increases linearly towards the downward side or the bottom side. If you can see in figure 1a, the height of water in the upstream side of concrete gravity section is H, and the pressure exerted on the bottom of this concrete gravity section is gamma H, as H is 0 at the top of water level on the crest side. Hence, the width of the basic triangular section for the concrete gravity dam is reduced in the upward side, and it is enhanced or increased in the downward side to cater the excess pressure. In the continuation of our discussion, I've told you about the water pressure P is equal to gamma H at the base, where gamma is the unit weight of water, having the value of 9.8 kilonewton per meter cube or 9810 newton per meter cube, and capital W is the weight of dam body. I have also explained to you about the widening of the top portion of the concrete gravity dam section for the vehicular movement for the dam inspection. Now I will tell you about the excessive flood water releasing over the dam section in the monsoon months. There is a provision for the concrete gravity dam. There is a provision of appropriate spillway on the concrete gravity dam section. As you can see in the figure, there are three terms. First one is shape of non-overflow section. Second one, crest profile of overflow section. And third thing is energy dissipation arrangement. In this figure, you can see crest profile of overflow section over which the excess flood water glides over the dam section. Further, energy dissipation arrangement is placed in order to cater the excessive hydraulic energy obtained from the axis spilling flood water to remove the erosion or to dissipate the energy from the high velocity flowing water. This energy dissipation arrangement is also known as Stilling Basin. Stilling Basin is nothing but the arrangement provided to release the excessive hydraulic energy which is obtained due to movement of water. It is the another form of kinetic energy which leads to the erosion of the bed material of the concrete dam section. As I have explained about the hydraulic jump energy loss in this figure 3, when water is flowing over a spillway, there is a difference between the energy at the very beginning of this figure. On the top, the total energy line resembles two positions at the crest and at the bottom. The difference between both initial and final total energy lines is nothing but the loss of energy in the hydraulic jump, and the stilling basin which is used for dissipate the excess energy to remove the erosion is utilized by the basin for the hydraulic jump. Now if we move forward on the spillway, this spillway is provided with a gate, and a typical spillway section is always having a radial gate as in figure 4. The axis or the trunnion of the gate is held to the anchorage that are fixed to piers. The practical limited width of this gateway is restricted up to 20 meters. In the gated spillway section, there is also provision of guide wall or a training wall which is used to separate out the flow of water from the one bay to another bay. The upstream phase of the overflowing and non-overflowing section of a gravity dam, as you can see in the figure earlier, overflowing and non-overflowing section is kept only in the single plane, which is termed as the dam axis or sometimes referred to as the dam base line. As you can see, the detailed coplanar upstream faces of overflow and non-overflow blocks. There are two blocks. One is non-overflow block and second one is overflow block, which is separated by guide wall or training wall. These are the base, and the top axis or top plane is dam axis. So for this particular concrete gravity dam section basic layout stop here. In the upcoming lectures we will discuss about the another terminologies or basic facts associated with the concrete gravity dams. Thank you for your kind patience. Stay healthy, stay safe.